Okay, Archimedes. So a very quick summary of the Archimedes Principle and also another property that Archimedes discovered. We start with the second one. So the story goes that Archimedes went into a bath. He noticed that when he put his foot in the bath, the water level rose. When he put 2 feet in the bath, the water level rose higher. When he immersed himself completely in the bath, the water level rose even higher. And he concluded that the amount or the volume by which the water level rose was exactly the same as the volume of his body that was submerged. So he said, or we say, the volume of an object submerged in a liquid equals the volume of fluid displaced. So the volume of objects submerged, let's say you got a football or a rugby ball and you submerged a little bit of it in the water, the volume that was submerged or immersed in the water would be equal to however much the water level would rise, so the volume that it rose. If you put the entire ball in the water, then the volume of the entire ball would be equal to the volume that the water level rises. And you would have done this in junior cert when you got the volume of a solid by immersing it in a liquid. So look at the diagram there. The initial volume of the liquid was 50 mils. A rock was put in it, and now the reading on the graduated cylinder is, I think, 82 mils. So what we know is the volume of water has risen from 50 to 82, so the volume increase, or the volume of fluid displaced, is 32 mils. That means that the volume of the stone or the volume of the object is also 32 mils. So that's the first thing he came across, or we come across. The second one is Archimedes' Principle. So Archimedes' Principle is as follows. He said that if you get a mass and you immerse the mass in a liquid, there'll be an upthrust, right? So if we look at the difference between the two diagrams, on the left we have 5 kgs, on the right we have 3 kgs. So the upthrust is 2 kgs, it's the difference between the two. But what Archimedes said is the upthrust is equal to the weight of fluid displaced. So when you put that 5 kg mass into the liquid, what happens is there's a spout there on the right hand side. A certain volume of liquid will be displaced and pour out of the spout, which in the right hand side diagram is caught on a little basin there, roughly 2 kgs of water. So the weight of that liquid that was displaced in that container will equal the upthrust. So if you were looking to show this, you would first have to calculate the upthrust. So get the weight of an object, immerse that object in a fluid, get its weight again, subtract those two weights to get the upthrust. Then get the displaced water, and you'd have to get the weight of the container, zero the mass balance, and then when you immerse the object in the water, catch the displaced fluid, and then get the weight of water. They should be equal. Okay, pause the video now. I'd like you to write up that experiment demonstration. Okay, I'm going to keep going. We came across this already, that if we have a floating object, that the upthrust is equal to the weight of the object. Now, if we unite that with Archimedes' Principle, which says the upthrust is equal to the weight of fluid displaced, I can replace upthrust with weight of fluid displaced. So we get the weight of fluid displaced equals the weight of the object. That's on the syllabus, and that second sentence there, weight of fluid displaced equals weight of the object, is apparently all you need to know. Okay, now an application of this law of flotation is the hydrometer. And a hydrometer, look at the top left diagram. A hydrometer is a container that's sealed. It's got a particular weight, and then if you put the object in liquids of different densities, it floats to different heights. Now, if you look at the image on the far right hand side, it's got a scale on it, and the hydrometers are calibrated to measure different things. So for example, the strength of battery acid. So when you use your car battery over a long period of time, the density of the acid in it decreases. So you can test the density using a hydrometer, and depending on the density, you can determine how much of a charge is stored in that, or you can determine the lifespan of that, or you can determine how much of the battery is left before it needs to be replaced. Hydrometers are also used in the milk industry because milk and cream are of different densities. So if you have a low-fat milk which has a low cream content, you would put the hydrometer in, the hydrometer would float very high, and then there'd be a scale on it, just like in the right-hand diagram, that would show you how much or what percentage cream is in it, so it would have a particular calibration. If you had cream, or a partial cream, or in the States they'd call it half and half, which is half cream I think and half milk, you'd put the hydrometer in. It would be a denser substance, so as a result the hydrometer would float higher, and then the scale on the right hand, the scale on the hydrometer would tell you how much cream is present in the mixture. And the last place it's used is in the wine and the spirits industry to determine how much alcohol is present in the wines or the spirits. And again, that just has to do with there's a difference in density between the alcohol and the water. More alcohol means that the mixture is less dense, so as a result the hydrometer will go down deeper, and then the scale is calibrated to tell you the percentage of alcohol in the liquid. Okay, so dense substance, the hydrometer floats high. Less dense substance, the hydrometer sinks deeper. And again, it just has to do with different densities as to what you're testing in each case. But the hydrometer is calibrated for each of those scenarios. So rather than having like a particular density value, in the case of milk and cream, it would tell you how much cream is there or what percentage of cream is there. In the case of wine, what percentage alcohol. In the case of the battery, what percentage of battery acid is left. Okay, weather and pressure is the last bit then. So this is very straightforward. On the left we have high pressure. High pressure just means that there's a very large weight of air above a particular point, and as a result then the air in that area is very stable. It's not likely to move, so there's no wind really. As a result, if the air is pressing down, the moist air can't rise, so clouds can form. So high pressure days are typically clear skies and little wind. By contrast then, low pressure days mean that the air is able to move, so it's going to go left and right, so it could be windy. It's able to rise as well, and as a consequence the air with the water in it rises and forms clouds.